In last class. Okay. Good morning once again. So in last class, shall I start the class? Ready? All of you get ready?
Recording in progress.
Okay. Now, yes, Amma, listen all of you. Last class we discussed about subset and proper subset definition. Subset and proper subset. Then tell me what is mean by subset? What is mean by subset? What is mean by subset? Tell anyone.
If set A is said to be a subset of set B, then if all the elements are present, then we call a subset, sir.
Very good. Very good, Amma. Let A and B are any two sets. In the two sets, every element of set A should be present in set B. Then we can say that A is subset of B. If A is subset of B, then B is
Superset.
Superset of A.
Let set A equal to 1, 2, 3, 4. Take another set B equal to 1, 2, 3, 4, 5, 6. Then tell me here, A is subset of B or A is not subset of B?
A is subset of B, sir.
A is subset of B. Very good. Here, A is subset of B. If A is subset of B, then B is
Superset of A.
B is superset of A. Superset of A. So is it clear these two concepts, subset and superset?
Yes, sir.
So after the concept, discuss about proper subset also. Then tell me what is mean by proper subset? What is mean by proper subset?
The subsets other than itself of a set is called a proper subset.
Other than itself, remaining all subsets are called proper subset. So let us take one example. Set A equal to A comma B. So here given that set A equal to A comma B. So in this set A comma B, how many subsets are there? How many subsets are there?
4, sir.
4 subsets. Then tell me that 4 subsets are
Empty set A, B, A.
Next one is B. Next one is A comma B. Comma B. So a set containing 2 elements. Then we will get 1, 2, 3, 4. 4 subsets. Now then, tell me. Let us take same example. Set A equal to A comma B. Then tell me how many proper subsets are there? How many proper subsets? Then tell me the proper subsets. Empty
Empty set
Null set.
A,
Set A, set B.
except itself, other than itself. Remaining all subsets will be named as proper subset. Proper subset. Here we have one formula for the subset and proper subset, right? So then tell me a set containing n elements. How many elements are there? A set containing n elements. Then tell me how many subsets are there? Then what
2
is
to the power of n.
finding number of
2 to the
subsets?
power of n.
2 to the power of n, sir.
2 to the power of n. Again, 2 to the power of n. Subset formula 2 to the power of n. If for example, a set containing 2 elements, then tell me 2 to the power of n. N stands for number of elements
in a set.
How many elements are there in the given set A?
Two.
2 elements.
Two.
2. That's why the answer is 2 to the power of 2. 2 to the power of 2 is nothing but 2 square. What is the value of 2 square?
4.
What is the value of 2 square? 4. That's why here we get 4 subsets. 1, 2, 3, 4. Is it clear?
Yes, sir.
Yes, sir.
Yes.
Take one more example. Take one large set. For example, set C equal to A, E, I, O, U. Here, set containing how many elements? 5 elements. 1, 2, 3, 4, 5.
5 elements.
Tell me, how many subsets are there? Then tell
32
me,
subsets.
how many subsets are there in the given set C?
32, sir.
32. Then tell me, what is the formula for that? What is
2
the
to the
formula?
5. 2 to the power 5.
2 to the power of 5.
Very good. Very good, Amal. 2 to the power of 5. Similarly, in proper subset also, we have formula. That formula is, actually subset formula is 2 to the power of n. So in this 2 to the power of n, in this total number of subsets, we should subtract one subset, that is itself, right? That's why the proper subset formula is 2 to the power of n minus 1. This minus 1 is nothing but itself. We should remove itself, right? We should remove itself. That's why this total 2 to the power of n subsets minus 1. Minus 1. Then this total formula is called number of proper subsets. Number of proper subsets to the given set A or B or C, whatever. Let us take one more example here. A set containing 2 elements A and B. Actually, how many subsets are there?
4.
4 subsets. Then how many proper subsets are there?
3.
3. 2 to the power of n minus 1. 2 to the power of 2. 2 square. 2 square value is 4. 4 minus 1. 4 minus 1 is 3. The 3 proper subsets are empty set, A and B. So the proper subset formula is 2 to the power of n minus 1. Not 2 to the power of n minus 1. Some of the students will write like this. This formula is wrong. Is it clear? 2 to the power of n separate minus 1. But 2 to the power of not n minus 1. That formula, once observe this formula, 2 to the power of n is separate minus 1. This is correct. Is it clear, all of you?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Now, the symbolical form of subset. If, for example, take 2 sets. Take 2 sets, A and B. So, the B is A, B, C, D. Then tell me, A is subset of B or A is not subset of B?
A is subset of B, sir.
Subset of B. That's why this can be written as in symbolically A, set name A, is subset of A is subset of, this is not, see, this symbol name is called subset. The symbol name is called subset. Subset of, another set is what we have?
B.
This is symbolical form of A is subset of B. And B is superset of A. That can be written as in symbolical form. B is, this is superset symbol. Okay, now this is C. This is not C. Okay, now actually we should write like C only, but we call it as subset. Okay, now reverse of C is nothing but this symbol name is called superset. Superset of A. B is superset of A. A is subset of B. B is superset of A. This is symbolical, symbolical form of subset and superset. Is it clear, all of you?
Yes, sir.
Yes, sir. Yes, sir.
we go for proper subset. We go for proper subset. Set A equal to A comma B and set B equal to take only A and B. Take only A. A is proper subset of B or A is not proper subset of B? A is proper subset of B or A is not proper subset of B. So the proper
A is not proper set of B. A is not
right? Proper subsets, right? These all are proper subsets. From these three proper subsets, take any one subset, any one proper subset. I am taking here A. So the given set A equal to A comma B. A comma B is the proper subset of set A or not proper subset of set A?
not proper subset of A, sir.
Not proper subset of A. Not proper subset of A. Why? 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 Take one example. For example, this only. Then tell me from the set A comma B, how many subsets are there? How many subsets are there? Four subsets. That is empty set A, B, and C. Sorry, and A comma B. Now, from these two sets, the set A comma B is subset of empty set or not subset of empty set?
Subset, sir.
From this set A comma B, A is the subset of A comma B or not subset of A comma B?
Subset.
Subsets, right? These all are subsets. That's why A comma B, empty set A, B, A comma B, these all are subsets. But here I am taking here A comma B, right? Proper subsets. Again, A, empty set B. These all are proper subsets only. From this set A comma B. From this set A comma B. Again, set A only, you should take only set A is the proper subset or not proper subset. Take I'll just take like this. Take B equal to A, B, C. A, B, C is the proper subset or not proper subset? Proper?
Yes, sir.
Proper subset, sir.
Why? Because every element of set A is in set B, right? It is a subset. If it is a subset, other than its subset, remaining all subsets are called proper subset. Remaining all proper subsets are called remaining all subset except itself. Remaining all subsets are called proper subset, right?
Proper subset.
Set A containing A comma B. Set B containing A, B, C. Then A is subset of B or A is not subset of B?
Subset, sir.
Subset, sir.
A is subset. Then A is proper subset of B or A is not proper subset of B?
Proper
A is
subset.
proper set, sir.
Proper subset? Proper subset. Proper subset or not? Tell me properly. Tell me confidently.
Yes, sir.
It is proper subset. Take one more example. For example, take one set builder form. Set A equal to X such that X is on prime numbers. X is on prime numbers. X is on prime numbers. Take another set B equal to X such that X is on natural numbers. X is on natural numbers. Natural numbers. Then these two sets are, first of all, subsets or not subset? A is subset of B or A is not subset of B?
A is subset of B, sir.
A is subset of B, sir.
Very good. If it is subset, automatically it is proper subset also. Because except itself, remove itself, remaining all subsets are called proper subset, right? So that's why if A is subset of B, automatically A is proper subset of B also. Is it clear?
Yes, sir.
Yes, sir.
So if A is subset of B, then A is proper subset of B also. Here subset form means A is subset of B. Then how to write proper subset symbolical form? A is proper subset means we should write only like this C symbol is nothing but this symbol name is called proper subset. We should not write in downside this symbol. So this is only subset of subset symbol. Except this downside symbol, you should write only like C symbol. This symbol is called proper subset. A is proper subset of B. A is proper subset of B. In our mathematics also, we have some conditions, right? For example, set A equal to X such that X is less than 5 or X belongs to natural numbers. X is less than 5. What is this meaning? What is the meaning of this statement? X such that X belongs to natural number. X belongs to natural number. Natural numbers are less than 5. Then tell me less than 5 natural numbers.
1, 2, 3, 4.
1, 2, 3, 4.
3, 4. 1, 2, 3, 4. If you take same condition, X such that X belongs to natural number, that natural numbers are less than or equal to 5. Then tell me what is the condition for that? What is the answer for this statement? X less than or equal to
5. Even 5 is included
1,
in
2,
2.
3, 4, 5, sir.
less than or equal to 5. That's why we should consider up to 5. Set A equal to 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Is it clear the difference between only less than and less than or equal to? Less than or equal to means we should write 5 also. If only less than symbol is there, okay now, it is less than 5 means we should consider up to 4. Here also, here subset of is nothing but equal to, subset of equal to. Equal to this meaning is we should consider as itself. The symbol is nothing but we should consider as itself also. Here, the symbol is not there, right? That's why here we should not consider itself. Then it is called proper subset. Then it is called subset. Is it clear?
Yes, sir.
Yes, sir.
Is it clear? My condition, my pain.
Yes, sir.
Yes, sir.
Sir, can you explain again once?
We should consider itself. Here equal to symbol is not there. Except itself, remaining subsets are called proper subset. So most of the students will write subset symbol like this. Proper subset also write like this. Some of the students subset symbol they will cover this symbol. Simply they will write A subset of A subset. This is subset symbol.
Sir, somebody
No,
is
sir.
asking to explain again. Someone is asking to explain again.
No.
Somebody is asking to explain again, sir.
Okay, madam. Okay. So subset and proper subset. I think you know very well the two definitions, subset and proper subset. So I will take one example, then only it will be clear to understand. I will take one more example. Set A equal to A comma B. Set A equal to A comma B. Again, so if set A equal to A comma B, set B equal to A comma B comma C. Then tell me A is subset of B or A is not subset of B?
A is subset of B, sir.
Subset of B.
A is subset of B. A is subset of B. Then tell me A is proper subset of B or A is not proper subset of B?
A is proper subset of B, sir.
A is proper subset of B. Let us say only one set A equal to A comma B. Then tell me how many subsets are there? Empty set, empty set,
Set A, set B,
Set
set A comma B.
last one is A comma B. A comma B. Here subset of is nothing but subset are equal to B. That's why equal to. If for example x less than 5, x belongs to natural number. I'm taking another example. Okay, now for understanding purpose, x belongs to natural numbers. X less than 5 means less than 5. 1, 2, 3, 4. We should take only 4. Right? So here less than or equal to means x less than or equal to 5 and x belongs to, this is x. X belongs to natural number. Natural numbers less than or equal to 5 means we should consider 5 also. 1, 2, 3, 4, 5. We should take up to 5. Here also A is subset of B. Subset of B. This is in our mathematical equal to. A is when a proper subset or subset are equal. Equal to B means we should consider as itself also. We should consider as itself also. Right? Proper subsets. Empty set A, B. Here there is no itself, right? There is no equal to symbol. Proper subset, there is no equal to symbol. That's why we should not take itself. That's why we should take subset symbol is when a subset in denominator, in downside, we should write just equal symbol. Here proper subsets, we should not write equal to symbol. This equal to means we should take itself. Here not equal to means we should not take itself, then only it is called proper subset. If you take equal itself set, then it is called subset. Is it clear?
Yes, sir.
Here there is no itself now. Here there is no itself. That's why then it is called proper subset. Then it is called subset. In subset, we should take itself. That's why here we should take equal to symbol. In proper subset, we should not take itself. That's why there is no equal to symbol in downside of the subset symbol. Is it clear?
Yes, sir.
Tell me, no problem. I will explain one more time also. Is it clear?
Yes, sir.
Sir.
Subset are equal to. This equal to is nothing but subset of. Actually, in our mathematics type, less than or equal to, right? Sometimes we will write like this. This meaning is what here? Less than or equal to. Equal to means up to we should take 5. Only if you take less than symbol, x less than 5, x belongs to natural numbers. X belongs to natural numbers. Less than 5 means we should not consider 5. Here also, this symbol is like equal to. That's why we should consider as itself. Here, there is no equal to symbol. That's why we should not consider itself. Is it clear, all of you?
Yes, sir.
Sir, I have one more doubt.
Yes, sir.
Tell me.
So you wrote there x less than or equals to 5, no? So x belongs to natural numbers.
Okay.
Then you have to write 2 sets or just 1 set, sir, including 5.
Set A equal to x such that x less than 5. Just for understanding purpose, I am taken this example. X such that x less than 5. X less than 5. What is mean by x? X less than 5. What is mean by x? Less than 5. X less than 5. What is mean by x? X belongs to natural numbers. This x stands for natural number. X stands for natural number. So that's why natural numbers are less than 5. So this type of statements also there in our sets concept. Coming next concept. This concept only, representation of a set. That is very, very important. Okay, now how to represent this set? So how many types are there for this representation of a set? That is also very, very important concept. So if you understand this concept clearly, I go for that concept only. Next one is this concept, this type of concept only. So otherwise take this example. X such x set A equal to x such that x is on natural numbers. Natural numbers less than 5. Then tell me what is the meaning of this statement? What is the meaning of this
Natural
statement?
number less than 1.
Natural numbers less than 5. Less than 5. Natural numbers less than 5. What is the meaning of that statement? What is the meaning?
Natural numbers less than 5, sir.
Natural numbers less than 5 means tell me that numbers.
1, 2, 3, 4.
1, 2, 3, 4.
1, 2, 3, 4. That's all. You should not take 5, right? Less than 5 means you should not take 5 up to 4. Take one more set. Set A equal to x such that x is on natural numbers. X is on natural numbers. Natural numbers less than or equal to less than or equal to less than or equal to 5. Then tell me what is the meaning of this statement? Less than or equal to 5.
Set A is equals to 1
Natural numbers from 1 to 5.
1 to 5, sir. 1, 2, 3, 4, 5.
3, 4, 5. Is any difference is there for these two statements?
Yes,
Is
sir.
any
Sir.
less than means we should not consider 5. Less than or equal to means we should consider 5. Here we should take only 1, 2, 3, 4, 5. Here we should take 1, sorry, here we should take 1, 2, 3, 4. Here we should consider as 5 also. 1, 2, 3, 4, 5. These statements should be write in symbolical form. How to write these statements in symbolical form? How to write the statements in symbolical form? Actually, this is one statement, right? This statement should convert to symbolical form, mathematical form. How to write this total statement means, let us consider that is set A equal to x. This symbol name is called such that. I think you know already this symbol name, right? Such that. X such that. X is on natural numbers less than 5. X is a natural number. X is a natural number. X such that x belongs to natural number, comma. Is it clear? X belongs to. What is mean by belongs to? What is the meaning of the belong? What is the meaning of the symbol belongs to?
X is a natural number.
Natural
X is
numbers.
a natural number.
This x should be natural number. That natural number, how many natural numbers we should take? Up to less than 5. That can be written as x less than 5. This is the mathematical notation. Mathematical notation or symbolical form of the given statement. These two statements should be same only. This is also x belongs to natural numbers, x less than 5. Here also x is on natural numbers less than 5. Is there any difference between these two sets? First two sets.
No, sir.
No, sir.
First two sets.
No, sir.
No, sir.
No. So coming to second one. So x such that x is on natural numbers. X is on natural numbers. That natural numbers are less than or equal to 5. So x such that x is on natural numbers. this natural numbers less than or equal to 5. This is also some statement form. This statement form should be write in symbolical form. So how to write? First we should write set name A equal to X such that the symbol name is called such that X such that. Here also X is a natural number. That's why X belongs to natural numbers. X belongs to natural numbers. Now, that natural numbers are less than or equal to 5. Less than or equal to 5. X less than or equal to 5. Less than or equal to 5. Then tell me, what is the meaning of this statement? X is natural numbers. Less than or equal to 5 means 1, 2, 3, 4, 5. We should take up to 5. Is it clear the difference between these two sets?
Yes, sir.
Equal to, if equal to meaning is there, then we should consider as 5. If equal to symbol is not there, only less than 5, we should write up to 4 only. Now, tell me, X such that X is on prime numbers. X is on prime numbers. X is on prime numbers less than 29. Less than 29. Then tell me in symbolical form. Then tell me in symbolical form.
Equals to such that X belongs to prime
P
numbers. X less than 29.
less than 29.
X is
Less than 29. Less than 29. Then tell me that less than 29 prime numbers. How many prime numbers are there? Less than 29. Tell me that prime numbers. Less than 29 prime numbers. 2. 2 is here.
Yes, sir.
3.
No.
Yes,
3.
sir. 2, 3, 5, 7.
Sir,
3.
2, 3,
3,
5,
5, 7,
7,
11, 13,
13,
17,
13, 17,
19,
19,
23.
20.
19,
23,
23.
sir.
23. 9, sir.
9 also prime number.
No, sir,
9
9
are
those
there.
numbers I'm saying, sir.
So less than 29 means we should not consider 29, right? Okay, up to take 2, 3, 5, 7, 11, 13. Next one is 17. Then after 19,
23.
23.
But in second set, X such that X is a natural number less than, sorry, X is a prime number. X is a prime number. The prime numbers are less than or equal to 29. Here we should consider 29. We should not consider here we should not consider 29. So in that also, if A is subset of B, if A is subset of B, A is subset of B is nothing but equal to symbol is there. That's why in this set we should consider itself. A is proper subset of B. In this set, there is no itself. There is no itself. Is it clear? This is subset of equal to means in this subset symbol, again we should consider itself. It is proper subset except itself. Remaining all subsets are called proper subset. Is it clear?
Yes, sir.
Yes, sir.
Sir.
Is it clear of you?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
Very good. So these all are different types of sets. Total different types of sets concept completed among. So once again listen from first to last types of sets. First one is null set completed. Next one is singleton set completed.
Explain universal set, sir.
Definition also completed. Infinite set completed. Next one is cardinal number. Cardinal numbers of the set also completed. Next one is equal set, equivalent set, disjoint set, overlapping set. Next one is subset, superset. Last one is proper subset. In that also one more definition also we discussed, power set. Power set. So these all are different types of sets. So total types of sets concept completed. Do you have any doubts regarding this concept?
Sir, universal set.
I will explain that. That is related to Venn diagrams. You know, Venn
Sir, once
diagrams.
can you explain about power set, sir?
Power set. Okay. Power set. Power set is first I will explain a small example. Then after you will understand the concept clearly. So take set A equal to 1, 2. Then tell me how many subsets are there for the set 1, 2. 4 subsets, right? Empty. 1, 2, 1. This is called subset. The collection of all subsets. The collection of all subsets are called power set. Collection of all subsets. That all subsets, when writing one set, then it is called power set. Is it clear? We, for example, write subset. In that subsets also, if you write like the symbols, in that subset, write in your bracket, these all are not subsets. These all are called
Power set.
Power set.